can post to D12, or sorry, to the Google folder if anybody was wanting to watch this and not getting a chance to come. Specifically though, wanting to know if there's any questions right now, either on one of the assignments or on one of the explorations. Can everybody hear me okay? Okay, and also you guys are welcome to unmute and talk at any point if you want to ask a question. I see Amber is asking about the third true false on quiz 5. So let me get that open and we can talk a little bit about that question. So are you talking about the one that is question like 4? It's listed as question 4. Okay, question 3. Okay, so the one that says if the correlation coefficient between variables x and y is positive, then the slope of the least squares regression line using x to predict y will also be positive. Is that the one we're looking at, Amber? Okay, perfect. So this is just asking about the sign, essentially, of correlation and the sign of slope. So obviously correlation coefficient and slope are not going to have the same value, but they would have the same sign. So if we have a positive correlation coefficient, we would have a positive slope. If we have a negative correlation coefficient, we would have a negative slope. Does that help you out there, Amber? Okay. Spencer, if you would type in the chat, type in your name, and I guess I know I'm your instructor, but you can type in. I'm just trying to keep record of who's attending.
Okay, cool.
Thanks. Do you have a question?
I thought I would check this out to maybe go through some of the stuff in quiz 10. Or the quiz that's due tonight.
Okay, cool.
Let me just get on that real quick.
And Sarah, if you would log or sign in too, that would be awesome. Just in the chat.
Sure. Do I how do I sign in?
Just type your full name in the chat to the side. I know I'm your instructor, so you don't have to put your instructor name. All right, does anybody else have any specific questions, either over the quiz or over the any of the explorations we've gone through this week or last week? Okay. Would it be useful to go like through some brief notes? Oh, sorry, another question over here. Can we talk about what we're supposed to do for the projects? Yeah, absolutely. So for the projects, I'm actually going to share my D2L screen with you guys, just so you can kind of see what I wrote out for my students. So if somebody could just weigh in and let me know that they are seeing my D2L screen, that would be awesome.
Yeah.
Okay. So for the project background and methods, there is a rubric. If you go to the STAT 216 website and down under the project instructions, it has a project draft components. That's the best place to look for complete information on what's expected. You're turning in the background and the methods. So the background is, why are we doing this study? Why is it relevant? You're supposed to come up with, off the top of my head, I can't remember if it's 2 or 3, but at least 2, if not 3 different sources that kind of support that study. You should also be reporting research questions in that part. And then also just the methods. The methods is talking about, well, what will you do with your data set? So you're going to talk about the variables you're going to analyze, a little background information on how the data set was collected. All that information is in that description of the data. Then you should also be giving descriptive and inferential methods that you plan to use when you assess your research questions. So you're not analyzing the data at this point. Descriptive statistics is like, what graphs are we going to create? What summary measures would we use for this study? And then types of tests that you'd use based on your research questions. Did that fully answer your question, Amber, or do you have other questions about that?
That's due Friday, right?
That's due Friday by 11 p.m. Yeah. And it is, again, a group. You should submit it as a group on Gradescope. Just make sure that whoever submits it adds the other people's names to that group.
Okay.
And Hannah, I see you logged in here. If you don't mind just typing in your name into the chat and your instructor name, just so I have that information. So.
Okay.
All right, any other questions? You can either unmute and talk or type in the chat.
Can I ask a question about the quiz that's due tonight?
Yes, absolutely.
So question 1.4 about the scatter plot shown with the line. It
Okay.
asks if it's linear or nonlinear. There is a regression line and it is pointed positively, but it's still such a messy scatter plot. It almost looks like there's no, or if it's a correlation, it's close to zero. But I can't answer my other questions unless I choose whether it's linear or nonlinear and I keep on going back and forth.
Okay, so when we look to see if it's linear or nonlinear, it's just kind of overall, what pattern are we seeing? Does it look like it has some sort of a linear relationship? And in this case, we can see that as temperature is increasing, that overall social warmth is also increasing. You're right, it may not be a very strong relationship, but it definitely shows a linear relationship. It's not curved.
Okay.
Okay.
That makes sense. Yeah. I was just not as sure. And it's nice to have someone say that you're on the right.
Yeah, definitely.
I had that same question, yeah.
Okay. Other questions that anybody has?
So I guess you kind of answered it earlier, but in the next one, where it says, what is the direction of the relationship? You kind of said as the temperature increases, social warmth also increases. So I would assume it's a positive direction.
Yeah. Anytime we see that as X increases, Y is also increasing, it's positive. If X is as X is increasing, Y is actually decreasing, then we have a negative relationship.
Okay.
And we could do a couple notes. I'll go ahead and post some or share my whiteboard and go over a few notes just talking about scatter plots, and then we can check back in to see how the understanding is going here. So just let me know if you can see the whiteboard. Can everybody see that whiteboard?
Yeah.
Okay. So when we're talking about scatter plots, there's 4 characteristics we look at. We look to see is the relationship, let's talk about form instead of, whoops, I forget how to use my whiteboard, right? Okay, so we look at form. So we're looking to see, is it linear? So essentially when we're looking to see, is it linear, we're looking at do our values kind of follow a nice linear pattern? If we have a non-linear pattern, we would see maybe more of a curved relationship between our variables, and that would be a non-linear relationship. You could also kind of see like a parabola relationship where we still have a positive relationship in this last graph here, but you can see that it's not linear because it's curved. Okay. Was there a question? Okay, looking at direction, if as X increases, Y is also increasing. That means we have a positive relationship. If as X increases, Y decreases, that means we have a negative relationship. Questions on those first two parts? So unfortunately with the whiteboard, I actually have to go to another page. I can't actually just push it up like on the .cam. So is everybody done with this information?
When you go to an exam and they ask you to state these, how do you want us to state them? Because I always get messed up on how to actually state them for exams. I know what I'm talking about, but like actually putting in words and like correct sentences and stuff always gets trippy when it gets to like stating what this means.
Okay, so like sometimes we'll just have it like even a multiple choice where you're just choosing, is it linear, nonlinear, strong, weak, positive, negative. If we were asking you to write out the relationship, it would be literally just using the 4 different characteristics. You could use it all in one sentence. Like I could say that there is a strong positive linear relationship between temperature and social warmth. I'm not saying that that one is strong, by the way. And then I would talk about outliers as well. So it's just the first 3, form, direction, and strength, are all describing the linear relationship or describing the relationship. So saying that we have a strong positive linear relationship or a negative weak nonlinear relationship or something like that. Does that help, Amber?
Yeah, I was just asking because like on the last couple exams or practice questions and stuff, when we were talking about other ones, we were talking about like what is the median or like stuff like that, and I was like, I always get tripped up on how to like say that right, even though I have the right stuff for it.
Okay, I understand what you're asking, and there's not really any like when we talk about the median, like a lot of times we'll ask you to interpret it. There's not really an interpretation here, so we're not going to say interpret the direction of the scatter plot. We would just ask, what is the direction of the scatter plot? So it's a little different that way. Okay, so then let's talk about, we talked about direction, so then strength. So basically here, this is going to be your measure of correlation typically. So the stronger or the tighter the values are to the line. So if we had a nice, perfect relationship, this essentially would be a positive correlation of R. So this would be strong. We could also have a strong negative relationship, right? So this would be R is -1, but that would also be strong. If our data points are way spread out where it's really hard to kind of get an idea, there might be a little bit of a direction here. This would mean that we have a correlation pretty close to 0, showing a weak relationship. Or we could talk about if we have values that are kind of a little bit spread out, we might have what we would consider a moderate relationship. So maybe an R of about like 0.7. Questions on strength? One of the questions in the quiz asks you to decide on what the value of correlation is based on the graph, and it's multiple choice. So you need to think about, is it a positive or a negative relationship? And once you've decided if it's positive or negative, that'll give you your sign of your correlation. So the sign of correlation equals the sign of the slope. And it also matches the relationship or the association on the scatter plot. Does that make sense? So if we have a positive correlation, we have a positive slope, that would also show a positive association on our scatter plot. So then also thinking back to that quiz question, then thinking about the strength. Is it a stronger relationship or is it a pretty weak relationship? So, all right, so the last thing we need to talk about, are we good with this page here?
Yep.
Yeah.
Okay, sorry, my kids are talking to me. And then the last thing we look for is outliers or unusual observations. And when we think about like a scatter plot here, if we have a value that is out here, it may be an outlier because it's not really fitting in the pattern of our data, but it's not going to be an influential point because it's not going to be changing the relationship of our variables. If we had a plot more like this and we have a value down here, this outlier is definitely going to influence our scatter plot, and it'll influence our slope and correlation. So thinking about outliers, this, like I said, would be a potential outlier, but since it's in the same line as our relationship between X and Y, we're probably not going to see that there's that it's influential, that it's changing our slope or our correlation. In class, we looked at if we change values, like we looked at if you change, like if we took this value that's in the center of our range of values and we moved it up or down, it's not going to have as big of an impact as if we took a value on the outside and moved it up or down. This value out here is going to have more of an impact on our slope and correlation than moving one in the center. Any questions on these 4 characteristics of scatter plots?
I do have one question.
Mm-hmm.
If the scatter plot is, there is a trend going, but it's still a very weak trend, and there's a lot of points that could potentially be outliers in a sense if it's not extremely strong.
Right, so just trying to look at ones that are not fitting the pattern of the data. So if they're, are you specifically talking about quiz 5?
Just in general with other things that I've seen as well.
Okay, so when we generally are talking about outliers, we want to say, is it fitting the pattern of data? So if it is more or less like within our data set, even like if we had a plot point out here, that one's probably not really going to be an outlier because it's kind of still in our pattern of our data. It's the ones that are like, well, that seems really, really weird. Like maybe I typed that in wrong, or maybe we just had a really weird observation. So looking for values that are definitely impacting our data set. Does that help with that, Sarah?
Yes, it does. Thank you.
Okay. Other questions? How are we doing with thinking about interpretations of like the slope and the y-intercept? We understanding those okay? Would anybody like to review interpretations of slope and intercept? Okay. All right, so I'm going to go back to the whiteboard here. I'll give like some kind of generic interpretations, and then we can look at the worksheet that I gave out. It's on the Google Drive, and we can talk about an example. So remember our line of regression, we look at our expected value of y. So our estimated value of the response is equal to the y-intercept plus the slope times our explanatory variable. So when we're talking about slope, you might remember from geometry class that slope is rise over run. So we're looking at our change in y divided by our change in x. So as x changes or increases, as x increases by 1, our y variable changes by our slope. So in words, it says, it looks like for, so I'm going to write interpretation of slope. So for a 1 unit increase in the explanatory variable, the expected, or you could say predicted, response changes by the slope. Okay, it's going to either increase if it's a positive slope or decrease if it's a negative slope. When we think about the interpretation of the y-intercept, this is when x is 0. So for when, I'm going to say when instead of for here. When x is 0, or the explanatory variable is 0, the expected response is the value of the y-intercept. We can look at an example, like I said, from the one from class, or not from class, from that I put on the Google Drive. So I'm going to go over to that. Does everybody have this screen written down? Have any questions on this screen? Okay. So looking at the review sheet, so it's looking at a random sample of 157 bills from a local Bozeman restaurant were collected, and researchers recorded the bill amount and the percent of the bill left as a tip for each bill. So we're looking at the tip bill percentage. So what are the variables recorded in this study? So we're in this study, we're going to be looking at the explanatory would be our bill amount, and the response would be the percent tip. Okay. So let's kind of looking at this scatter plot here, and we can also see a couple values down here. It gives the correlation coefficient of 0.135, and there's our slope. Let's talk about a couple things on this study. So let's talk about those 4 characteristics that we just reviewed. Overall, does it look like it has a linear relationship? What do you guys think?
It
I
does
think
look
there's,
linear.
yeah.
Okay, yeah, I'd agree. It has a linear relationship. How about direction? Is it positive or negative?
Positive.
Okay. Strength. weak, moderate, or strong?
Moderate. So the outliers.
So because we do have some outliers and our R value is so small, this is definitely a weak relationship. If we took these, not that we'd want to do that, but if we removed these outliers, then we would probably be able to say it's a moderate relationship. But because we have those outliers up there, it's definitely a weak relationship. Also, we can look at that correlation. So outliers, we definitely have these two for sure would probably be considered influential points or outliers. This point here maybe could be a potential outlier, but I definitely say those two up there. Do you have any questions? Okay, we can see our line of regression right here. So here we could, if I writing it here, it asks for the variable name. So I'm going to write percent tip. And remember, this always has a hat on it because it's a predicted value. Our y-intercept is 15.51. Our slope is 0.0488 times the amount of the bill. So any questions so far? I'm just going to see if we'll go ahead and interpret the y-intercept. It's not one of the questions on here, but we'll go ahead and interpret the slope for this study. So I'm going to write it up here.
I'm muted right now.
Actually, you're not.
Oh, sorry.
That's all right. When we interpret slope, we're talking about a change in x, so an increase in x, what happens to our y variable. So for an increase in bill of $1, because we're increasing by our units of x, the predicted percent tip, is it increasing or decreasing?
Increasing.
Yep, it's increasing because we have a positive slope. Increases by 0.0488%. Is everybody following how we found that interpretation? Okay. Some of these other questions are thinking about, well, how could we predict? So if we're using a prediction, we're predicting for a specific value of x. So this goes into our equation for the x value, and we'll find then that predicted tip, percent tip. Okay. So I'm going to cheat and write percent like that just to make my life a little easier. And we're multiplying that then times our bill amount. Everybody following where these values came from? So if you do the calculation, you should get 16.28%. Anybody have any questions so far? Anybody still there?
Yeah.
All right. All right, so this next two questions are gonna get us thinking about the residual here. So if the tip left for a bill of 15.73, $15.73, we can find the percent tip by taking the tip divided by the bill amount, and that gives us a percent tip of 31.79%. So this is an observed value, because this was in our data set. So for a bill of 15.73, the percent tip given was 31.79%. It's a pretty good tip. So we think about, well, okay, what does that mean? So was this person stingy or generous tipper? So what we're going to look at is finding the residual. So to find the residual, we take our observed value minus the predicted. The observed is this 31.79. That was the percentage that we saw in the data set. And the predicted is the value that we found up in part D. So that gives us a residual of 15.51%. So what do you think? Does this show that this person was stingy or generous?
Average.
Well, this value is our residual. Would it be above? Would this point, this 15.73, 31.79%, would that value be above the line of regression or below the line of regression?
Above.
Above, because of a positive residual. So since they're giving more than what we expect than our predicted value, they would be a generous.
Generous. Okay.
Okay. Oh, there's my interpretation of slope down here. Okay. So looking at that next question, which would be the correct interpretation of the slope?
Answer B seems to have most of the parts where we were
Okay.
interpreting.
Yep, I'd agree with that. That is our slope value. So as we increase bill amount X by $1, we expect the tip percentage to increase by 0.488. So yeah, that would be the correct interpretation. All right, we'll talk a little bit about coefficient of determination, then I'm going to give some notes on the null and alternative, and then we can kind of continue on talking about this study. So there's two ways we can calculate the coefficient of determination. We can take the standard error, sorry, the sample, the sum of squares error, there we go, for our regression, or the y bar for our average, divided minus, I'm struggling here, minus the sum of squared errors for the regression line. And then divide by our sum of squared error for y bar times 100%. We could also find this value by squaring the correlation coefficient. We're given these values for our sum of squares errors, so we're going to use them to calculate our value. So this is going to be 3001.06 minus 2,946.13 divided by 3001.06 times 100. And that gives me a coefficient of determination of 1.83%. We ideally would like coefficients of determination close to 100%. And we'll talk about our interpretation of this. I'm gonna have to, I ran out of room to write there, so probably gonna look at, I'll use the whiteboard, I think, to write out that interpretation. Anybody have any questions on this calculation that we just found? Okay. So when we interpret the coefficient of determination, and this is our R squared value. It looks at the percentage of the variability or the variation in the response that is explained by the relationship with the explanatory variable. So for this study, the TIP study, we'd say approximately 1.83%, because that was my coefficient of determination of the variability or the variation of tip percentages. The response variable is explained by the relationship with bill amount. Questions on calculation or interpretation of the coefficient of determination? Okay, we'll talk a little bit about tests of slope and correlation. So testing, essentially when we test slope and correlation, we're testing the same thing. So the null assumes there is no linear relationship between the explanatory variable and the response variable. And because we need to have population in here, I could either put true up here or could say in the population. Remember, hypotheses are always about our parameter, about our population. Okay, and then our alternative, that's going to depend on our research question. We do a two-sided test. We'd say there is a linear relationship between the explanatory and the response. But we could also look at a right-sided test or a left-sided test. So if it was a right-sided test, we'd say there is a positive linear relationship. If it's a left-sided test, we'd say a negative. So if we had that we were doing a positive linear relationship, oops. This is going to test that either our slope is greater than 0 or our correlation coefficient is greater than 0. If we were looking at a negative linear relationship, we'd look at that our slope is less than 0 or our correlation is less than 0. Everybody following that? Slope is, we use beta for slope. So beta is slope notation for the parameter and rho is correlation. Questions on the null and alternative hypotheses? Does everybody have everything from this page down, or do you need a few more minutes? Okay. So if we go back kind of to looking at our review sheet, in words, we can just talk about, in our null, we would talk about there is a linear, or there is not a linear relationship. So there is no linear relationship between okay. There's no linear relationship between bill amount and tip percentage. What about the alternative? Are we specifying a direction in part I if the tip percentage increases with the bill amount? Are we indicating a direction here?
I think it's just relationship and not increase or decrease.
Well, it's showing, it's saying tip as if
Oh,
the bill,
tip percentage increases. Yeah, so there's a.
so it's talking about as bill increases, is tip also increasing? So it's looking at positive. I just stuck that word true up there because I realized I didn't have a population word in there in my null. So here we would talk about there is a true positive because we're doing a right-sided test, linear relationship. Between our bill amount and the tip percentage. Questions on the null and alternative there? Okay, we have our Rossmann chance output. This is our null distribution over here. This is showing just the most recent shuffled sample, so we don't really care about that. But this is our null. We're plotting slope here. So it's asking, what did they do wrong? So our value of slope, remember, was 0.0488. So can anybody identify what was done incorrectly to calculate the p-value? So this is right here. This is our slope. What about the direction? Is the direction correct? Should we be counting beyond?
No, beyond would be a two-sided.
Right, the beyond would give it two-sided, so this should be greater here, because we should be testing a right-sided test, because we're trying to show that it's as the bill increases, the tip percentage is also increasing. Does everybody understand where that was wrong there? So what would be the correct p-value? How could we find the correct p-value from this? How does the one-sided p-value relate to a two-sided p-value?
Aren't two-sided like larger and not as reliable as a one-sided is?
Okay, and they're approximately double. So to find the p-value for this study, we could take the 0.0935 and divide by 2. And that would give us an approximate p-value. So about 0.047 would be our p-value. So we only have like 2 minutes left of these. Would you rather talk about the randomization sample, how it's created, or the conclusion?
The conclusion.
All right, good. So a conclusion, we look at the amount of evidence for the alternative. And our alternative, remember, we're looking at a right-sided test that as bill percentage increases, or sorry, as bill increases, our tip percentages increases. So that p-value of 0.047 is moderate evidence, or moderately strong evidence. So we have moderate evidence that there is a true positive linear relationship between bill amount and tip percentage. Because we're talking about evidence for our alternative, and that was the alternative that we were testing. Questions on that? Any other quick questions before class is over?
I have a question on the quiz
Sure.
that we have. The question that says there's one observation which could be argued appears to be far from the rest of the data. Would you anticipate this play being influential? And I put yes, but I don't know like what the reason is of that is, like why it is.
Okay. Any chance you know which question that is off the top of your head?
1.6.
Okay. Okay, so when you look at the plot, look at where that value falls. So that one is kind of right in the middle kind of our X values. Would you agree? But kind of low for our Y values.
Yeah.
So if you remember in class, we moved observations that were close to the center of the distribution, and we saw that those didn't have very big impact on our slope or correlation as ones that were far out in the tails. So because this value is kind of similar to our range of X values, we wouldn't expect it to have that big of an impact on our study. Does that help?
Okay. Yeah.
Any other questions? And I will start kind of another session at 3:10, which you're welcome to hang out for if you want. If you're just adding in, if you would sign in through the chat and just put your name and then your instructor's name as well, would be great.